Okay, objects. This is where we left last time. And I was making a point to say, this isn't a harder topic. If anything, a lot of people find this almost like a step backwards in terms of difficulty. Backwards, I think it's not as difficult because it kind of goes, it's focused more around the basic stuff we've been doing. But it does have a bit of a paradigm shift in how we're going to be coding things. Because we're going to be switching to more of an object-oriented style of programming. The merits of object-oriented style programming versus not, that's not a discussion for right now, but it is another style of programming. Now, turns out though, you already have been doing some object-oriented programming. What you've been doing is you've been using objects. Let me make sure I'm recording. Yes. You've been using objects. You have used lists. Lists are objects. And lists have methods, like append, right? Lists also have a length, right? So properties about them. So objects will have properties about them and functionality that's tied to them, okay? Same with strings, right? Strings, right? They're objects, they've got some methods on them and whatnot. There are other objects we played around with. But where we're going now is yes, we're still going to be using objects, but we're also going to be defining and creating our own objects, where we say, what are the properties associated with this object? And what's the functionality we want to associate with this object? So why do we like objects? Well, in the same way that a function can generalize, a function generalizes some functionality, it abstracts some functionality, right? If I made a function calculate compounding interest, inside of there, okay, there's a bunch of code, but I don't need to think about that internal code anymore. I interface with that function. An object is another step of abstraction, where you've got collections of functionality and data that you're kind of encapsulating, like a list, right? You see what I mean? A list is not just a single function. There's a bunch of functions associated with it, and there's a bunch of properties associated with it. But I can think about it as a list at this more abstract level of a list, okay? You didn't have to write the list class. You didn't write all the code to define a list, but if you wanted to, you could go open up the hood and look at the code in Python that defines what a list is. And it's going to look a lot like what we're going to be seeing very soon. Yeah, okay, so lists you've already been using, they're objects. They have some data associated with them, like the information actually stored in the list and their size, but they also have some functionality associated with them, like remove, append, and there's a lot more. And I showed you before, if I made some list, A equals whatever, and then A dot, here's all the append, clear, copy, count, extend, index, right? There's a lot of methods there that I could use. These are all different pieces of functionality that are for a list. But they'll act on let's make sure this is obvious. Because it's probably obvious, but somehow both lists have a length, right? But what's the length of A? It's 3. What's the length of B? 1. So they both have a length, but their lengths depend on, well, which list are they? Right? See what I mean? If I were to say A.append 66, is B changed? No. Why would it be, right? You said append to this one, right? So yeah, it's got a method, but it's tied to the specific list, right? These are two different lists, the one referenced by A and the one referenced by B. If I append to A, which one's changing? That one, obviously. So the methods are tied to functionality about that specific list, Not all lists. All lists have an append, but when I append something to A, it's only the list referenced by A that we're modifying. You see? It might seem obvious, but this is an important note. All right, so you're already used to working with lists, but you have not defined your own objects. That's what we're about to do. We're going to talk about the basics of how to define our own objects. You'll notice, too, that we have several topics, objects 1, 2, 3, unit tests, which is very related, and then 4. So there's a lot about objects I'm going to introduce. I'm going to start with the basics, and then I'm going to kind of like add some nuance as we go. All right? And then we're going to work our way up to something we call data structures, which are not these like non-trivial objects like lists, right? We lead to data structures because, I mean, that's what all assignment 4 is about. But that's like what 162 is about, is data structures, right? So we're working towards data structures, which are these non-trivial objects. The earlier objects we're going to be making, they're called like plain old objects. Like, that's what they call them. Plain old, I guess in Python they call them like poo-poos. Plain old Python objects, popos, something like that, right? And then there's like POJOs, plain old Java objects, whatever. Basic objects, they just store data and or functionality. All right. Classes versus objects. These words are often used interchangeably, but there is a difference. We are going to define what it means to be a circle in our program, okay? In order to effectively, I want to be able to have like circle objects, all right? Why? What do I want to do with it? Just hang in there with me, and I'm just making this, it's a contrived example to just make an object. There's no magic behind it other than like we're just going to make a circle. In order to make circles, though, like if I go to Python and say like, okay, I want A to be a circle. This is like how you would like make it print A. It's going to say, but what the hell is a circle, right? Because I never told Python what a circle is. I never defined a circle. In the same way that if I'm like, okay, call the function, this does not exist. If I call this function, well, it crashed above it. If I do this, that's not defined. How could I call a function if I didn't tell Python what that function is? I need to define it first. So in the same way that we define functions, we need to define a class. The class is where we say, this is what it means to be a circle. It's effectively the blueprint. So we define the class, and then we can make as many instances of that class as we want. The instances of the class are what we call the objects. The thing that defines how to make an object is the class. People will use these words interchangeably a little bit, but that's what the difference really is. The class is the definition. All right, yeah, for example, we're defining a circle class, which contains all the information needed for Python to go and make an instance of a circle. You can think of, like a blueprint, going back to the list. There exists a class definition like the blueprints for lists. With the one class, I can then create as many instances of lists as I want. If there's one definition of a list, I can make a bajillion lists. I just need one set of blueprints to then go make it. All right? Any questions so far? It's really quiet, and everyone's got a pretty rough stare right now, so I don't know what's happening. Are you happy or sad? I'm hearing not, okay, happy? When I say, are you happy or sad, and I hear, or I see this, it's ambiguous. Both? What's happening? Very good. All right, so let's define a circle class. We're going to learn by doing. So in other words, we're going to define a circle class, make a few instances of circle, give it some functionality, give it some data, interact with them just to get a sense of like how we do it and how we can use it. All right? But we have to answer a question. Okay, what is a circle? First of all, look, when I'm writing the code in my program, I know that when I tell you to like go do an assignment, right? And like, okay, go build this class, go do this, go do that, right? You do what I tell you to do, fine, right? But let's take a moment and think, like, if you're writing code and I didn't give you instructions, I'd just say, oh, just go implement tic-tac-toe, right? But I don't give you any specific instructions. You have decisions to make, right? So however you do it, it's entirely up to you. So you have to define, like in this case, like, okay, well, what is a circle? I have to decide what I want my computer to know about and care about, my program to know about and care about circles, to define it. So what do we need for a circle? Well, we get to invent it, right? Like, we are the God in our program universe, all right? We get to decide what data we want to store in the circle. Now, obviously, what data should a circle have? Things relevant for a circle, all right? Like, if I were making human objects, if I were to define class student, for example, the data could be things like their first name, their last name, their email address, student number, right? All those things. But like, you want the data to obviously be relevant for what you're doing. You're not going to give human objects like a radius. What does that even mean, right? Like, you make sure it makes sense for what you're doing. So we get to define it, yeah, but we obviously want it to be a reasonable thing. So if we want data for a circle, it probably needs a radius, right? And that's really all we need in terms of data, I think, for our program about circles, okay? Is a circle object, all we really need to do is, all it needs to know is its radius. Then, with a radius, like, what else do I want my circle to be able to do? Well, I want to be able to get like the circles like basic geometry questions, like circumference, diameter, area, right? Stuff like that. Why? Because it's my program and that's what I'm going to do. So that's my goal right now. Do you understand what I'm trying to do? So the circle, every object, is going to be made up of data and or functionality. Sometimes both, sometimes really only one or the other. It's whatever. There's some design decisions that we could get into here that we're not going to this semester. That's going to be talked about more next semester. But in general, the principle is we're kind of combining data and functionality together. So let's start defining a circle. We use the keyword class to tell Python we are defining a class. Then we name the class. Like something like this. Now, here, you might notice some interesting things about what I did here. This is not snake case. Remember with the underscores? You separate words with underscores. You don't do that with classes in Python. You use camel case, which is you separate words with an uppercase, right? So this is some name. Now, technically, this isn't camel case, because camel case, the first letter starts with lowercase. This is called something else, I can't remember. But another thing about classes is, unlike everything else in Python, where it's like all lowercase, you know, you want things to be like lowercase. With classes, they always start with an uppercase. It's a convention. If you don't do it, it'll work. But if you don't do it, you're breaking the rules. The Python police will come get you, okay? So the convention for classes is camel case, start with an uppercase. And there's nice value there, because if another programmer comes along and sees something in there with an uppercase, they immediately, oh, that's a class, like that's an object. They'll know immediately, right? So there's information embedded in the syntax. Because I see that word written that way, it tells me a lot about that thing. In the same way that constants, right? The syntax of a constant, all uppercase, right? Even though that's a syntax thing, because of like the knowledge about like, oh, there's a lot of meaning. Oh, it's a constant, that means I don't touch it. It has special importance, it's got a very important name, right? There's a lot of actual meaning associated with that syntax, which is interesting. Now, Here, we want a circle. Circle. It's not 2 words, so I don't really need to worry about that camel case, but it does start with an uppercase. And then a colon. All right? Indent. Usually before every indent in Python, you've got like that colon, right? So now, like with a function, or an if statement, or a loop, all of the code in the function, in the definition of the function, in the for loop, in the if, right? It's all indented. So all the things that are a part of this class are indented. Okay? Here it's got a docstring. This is for the description of the whole class. I'm not going to include it when I copy it over just for space, but there is, that would be there as well. All right, so class circle starts the class. Anything indented is part of the class. Like how anything indented in if, right? The docstring comment there, cool. Any questions so far? Right now, in fact, if I do this, by the way, I talked about this. Did I talk about pass last time in lecture, or was that in lab? The pass is a line of code that means do nothing. We did, okay. So, and why would we want that? Well, for example, in this particular situation, whenever you have like a colon and an indent, Python requires there to be something there. But if something needs to be there, but I don't really want anything to be there, I mean, I can say like a equals 1, and then like that's like whatever, something's there, but it's useless. But if another programmer comes along, they're like, why? What does that mean? Is that important? What's going on, right? So there's a special keyword, and that, oh, that's just nothing, right? So here, we've got a class, it's an empty class, but interestingly enough, with just this, because of something called inheritance, which we don't really talk about yet, I could actually go and create an instance of the circle class. I can make a circle object already. So now I can go like down here, for example, and say my circle equals, no, I should do the right way, equals a circle. Boom. It works now because I've defined the class. Now, there's nothing in there though. I haven't given it any data. I haven't given it any functionality. But I can say print my circle, and I see something like that. It exists. It's a circle object at, this is like a memory location, right? So it's somewhere in RAM. And then we can do like type of my circle as well. Print out the type. It's a circle. Circle. Great. So it exists. It's a circle. But obviously this is a rather not helpful object at this point, right? The class doesn't, it doesn't do anything. But we can make an instance already. Usually then, okay, here, yeah. For example, I just showed you this. However, it's not particularly useful. So, often what we start with is what we call the constructor. Now, asterisk. In Python, it's actually not the, if you really were to dig into the nuance of Python and how it works, it's technically not a constructor, it's something else, but for all intents and purposes, we're going to call it the instructor, okay? Constructor. The constructor is a chunk of code that is run whenever you make an instance of the class. And it's basically where you put the setup, okay? It is when you make an instance, this right here is making an instance of a circle. You put that in there, you say that, it runs the code in the constructor, and that's where all the setup code for your object exists. The constructor has a very, 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 very important name. It needs to be underscore, underscore, init, underscore, underscore. It must be that. If it isn't that exactly, it's not a constructor. In fact, I I'm certain it's not just me. There, I'm adding this, oops. I'm certain it's not just me, but I have a really bad habit because of like code completion. I have a really bad habit of typing this in, which actually means something entirely different. That's another keyword, but not for constructor. And then it's always mad, like, oh, it's not defined. How does it know? There's no constructor. And I'm like, well, it's right there. It's because I put int, not init. It must be called init. All right? Now when I hit run, okay, now we've added that. I go down here, I hit run. Great. Cool. But I have some code in the constructor right here. We also see this weird word called self. We'll come back to that very shortly. It's a weird concept at first, but it makes perfect sense 2 seconds later. To convince you, though, that the constructor is called, I'm going to say print I'm just going to add a print function called a print inside the constructor. So when I run this line of code, if calling this actually runs this constructor automatically, then this should be printed out, right? So, perfect. Right? How does it know to go call init? Because that's how Python's built. If you ever call the name of the class, whenever you create it, this is like creating an instance of circle. This is calling the constructor. It goes and runs the init automatically. Okay? So how does it know? Because whenever you do it, Python knows, oh, run the init for that class. Which class? The one you're making an instance from, and it knows because that's what it's called. Okay? Different languages do it a little bit differently. This is how it's done in Python. When I run this code now, what do you expect to see? This is not a trick question. What do you expect to see when I hit run right now? The same thing. Can you be more specific? Yeah. Why? Because I made 2 instances. And every time I make an instance, it calls this init function, which just prints something out. All right? Okay. Now, I'm going to go back here and go back to here. Now, okay. Here is a rule in Python. The rule is every function that we have inside our class, which we don't call functions, we call them methods, by the way, but same idea. The first parameter is called, well, the first parameter is a super special parameter. We call it self. Now, it actually doesn't need to be called self. You can call it whatever you want. Don't you dare ever call it anything but self, though. Okay? Again, the Python police. And that's a bad one. That'll sound like the Python FBI after you. So it's always got to start with this special thing called self. But what is self? Well, self is a reference variable that references the current object. Okay? And I'm laughing, I'm smiling because this is usually where people go like, what? It's a reference variable that means itself. Okay? And then here, I'm saying radius is 0. But it's not just any willy-nilly variable radius. No, no, no. It's radius, which is a variable that belongs to the instance of the circle that we're creating. All right? So, if I go, and let me try to make this a little bit more concrete for you, okay? So if I go here and I make a circle, right? But now I'm going to say print my circle. What's with these pop-ups? Dot radius now. it's 0. So what did this code now do? Well, the initializer goes and it creates a variable that belongs to the instance of the circle that's being created, and its value is 0. Now here, I'm saying, well, my circle, which is a reference variable to that circle, give me your radius. I can even go here and just do like something like my circle dot radius equals 199. Well, now it's 99. Now, but like, okay, self. Think about it like this. I'm defining a class. And I say whenever, like in init, right? Whenever some object is getting created. Remember, the class is like the blueprint. The object is in like RAM over here. Okay? But when we have self, like so every instance of an object in Python and a lot of object-oriented programming languages have a reference to itself. So we say like, okay, so radius is getting set to 0. Whose radius? Whose radius is set to 0? My radius is set to 0. Okay? Now here, I create a variable called my circle, which is a reference variable to the circle that was just created, right? So now when I say my circle.radius 99, I go to the one I'm referencing and like, oh, it's 99 now. Okay? It's a reference variable to the instance that we're messing with. All right? Self is going to come up again a lot more. And by the end of like, maybe not this topic, but the next topic, there's going to be something in there that should make it even more clear. But self is a big one. It's going to be important to understand as you go. In other languages like Java, it's called this. Not self, they call it this. But whatever. Any questions so far about what we're seeing? And, like I said, the first parameter in every single method that's associated with the instances that we're creating in the definition of the class, every method that we want to belong to like instances have to start with self. Okay? They must. It's because they call it like the implicit argument or the implicit parameter. I'll show you what that means once we write another method. All right, so init. Okay, in the above example, we see the use of a special function called init, and it describes how to initialize the class. It's called the constructor or the initialization method. There's some weird nuance there in Python that really doesn't matter. We can also see that we're creating what we call an attribute. An attribute is a variable, but it's associated with an instance of an object. In the same way that like a method is a function, but it belongs to some objects. All right? It's just data. It's like a variable. Okay? We just give it a special name. If you hear attribute, you're like, okay, it's a variable, but it belongs to an instance of an object. Just like the length of a list. Two different lists they both have a length, right? But their attributes, their values will differ depending on what is the length of each individual list, right? Similarly with circles, we can have a bunch of different circles with a bunch of different radiuses. Each circle will know its own radius, but that's it. Okay. Okay, you will notice a special variable called self in the parameter list and before the attribute radius. Self is a reference variable to this thing, the current instance. All methods within the class require that the first parameter is the self reference variable. Additionally, accessing any attribute or method within the class has to happen with the self reference variable because anything in an object must be accessed via a reference variable, whether it's something from outside the class or from within the object itself, which is interesting. Self variable can feel a little weird at first, but it's going to make sense the more we go. All right, so with init written, we can do this now. Perfect. I'll copy this. Perfect. Perfect, right? So I created two circles, circle A, circle B, right? Well, really, they're two circles that I'm referencing with the variables circle A and circle B. These are reference variables, just like it would be with lists. And then I'm saying circle A, your radius is 4. Circle B, your radius is 5. So notice, both circles have a radius, but they are entirely independent. When I say circle A, what's your radius? It says 1. Circle B, what's your radius? It's 5. Why? Because I changed circle A's radius to 1 and B's to 5. Obviously, right? If the attribute thing still throws you off, everyone in here has a first name. You all have a first name attribute. But your names are different. And that's fine. So you all have a first name, but your names are different. You all have a height, but your heights are different. You all have a hair color, but the hair color is different. All right? That's what we're doing here. Okay, any questions about what you see here? Okay, yeah. All right. However, we can actually make use of additional parameters in the constructor to kind of eliminate what we just did, right? Like here, we created instances, immediately updated the values of the radiuses, because whenever we made an instance, the radius was set to 0. We immediately update it, and then we print it out. So what we can do instead is add radius. It doesn't need type hints, right? But I'll add it. Cool. Right? Now, instead of whenever you make an instance, you assign radius to 0, no. I'm going to assign radius to radius. Now, if you're thinking to yourself, wait, hold on. You're reusing the same name. You're right. First, let me show you it a different way. I could call this like, and this will work. All right? There's clearly no ambiguity in the name of which function is what, right? Radius versus radius. In fact, if I go here, I'm going to get rid of those lines. And here I'm going to give it 1 and 5. Oh, what did I do wrong? Oh, I didn't rerun this yet. Cool. There. All right, cool. So same functionality. I just kind of put that functionality inside the constructor. Is I say when I call the constructor, you're going to get a value called QWE, and you're immediately going to take the value stored in QWE and put it into self.radius. Okay? QWE, of course, is a terrible variable name, so we're going to call it radius. If I rerun this, it's going to work just fine. If you're worried, though, like, well, hold on, I've got like a conflict here. This is ambiguous. I've got 2 radius variables. How do we know which one's which? Because one is just a variable. The other is an attribute. And I know it's an attribute because it says self dot in front of it. So even though they have the same name, they are entirely separate. There's no ambiguity. So it's a common pattern to, like, whatever these parameters are, to just be named after whatever attribute they're standing in it for. Do you understand? Yeah? So there we go. Cool. Cool. Now you'll also look at this and be like, well, hold on. When you look at this parameter list, how many parameters are in there? 2. You only gave it 1. But it needs 2. Well, deal with it. The first one always has to be self. It's just there. If you just have self, like, watch even what it says. Okay? If I hit run, it's saying takes 1 positional argument, but 2 were given. So it knows that self, it's counting self, right? And it takes 1 argument. It's right there. But when here, you don't see it. But it's there. In fact, it's saying like, but 2 were given. And you're looking here, you're like, but there's only 1. There's only 1 value there. How is it saying there's 2? Because it sneaks in that self whether you like it or not. Oops. There. All right? Questions, 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 questions. Ask now, please. All we've done is defined We started to define a class, we started to define the constructor, and we made the constructor a little bit more general by giving it a parameter. There we go, cool. With that, we can make instances and get access to the attributes. I suppose we also created an attribute, right? Self.radius, boom. I can do like blah equals 90, no, blah, right? Run that. I can give this object as many attributes as I want, right? But it needs to exist. Like, well, that doesn't exist, right? Circle object has no attribute, whatever, right? But yeah, radius. I'll get rid of blah because that clearly doesn't do anything for us. But we can have as many as we want, all right? And they don't all even need to be created in the initializer. They can be created elsewhere, but it's common to see a bunch created in the initializer. Also, listen very carefully because this always messes people up, especially once we get to data structures. Here I'm giving you one, it's immediately going straight to the attribute. But it's very common to have think of when you create a new empty list, right? That list will have a size. But when you made the list, now the syntax for a list, lists are a little special because they gave it like syntactic sugar. But like you don't make a list like this. Right? Like that's not really how you make lists, right? You make them like this. But the analog to like how you would make a list if it was like a regular style object with the same syntax would be like that, right? This is how I would make it. Now, the list has an attribute length. Did I give it a value to set its length? No. But when you make a new empty list, you know what its length is. So all I'm saying is objects can have attributes that you don't set. It just is like implicit. It's normal. Anyways. Cool. All right, in the above example, we include the parameter. This way we don't need to set the values. Perfect. Yes. Awesome. Now we can add functionality, the methods. All right, so what functionality do we want our circle to have? Well, we can do whatever we want, but how about diameter of a circle, right? If I know the radius, I can get the diameter, right? The area of a circle, if I know the radius, I can get the area. And the circumference of a circle. If you're like, well, why? Just because, right? This is what I can do with a circle. It's a contrived example, but we all agree I could ask a circle to calculate these things and give me back the value, right? Yeah? So we could start to define these pretty easily. The values here, I'm not storing the diameter, I'm not storing the area, and I'm not storing the circumference. Although we could design this object such that it does, but I'm not storing that information. I'm only storing the radius, and I have to calculate this. So there needs to be some like functionality to calculate these things, right? So we can add the function diameter. Okay? It's including type hints here. And I'm just going to get rid of the doc strings for brevity. There. Diameter. All diameter is going to do, if I ever call diameter, notice the first parameter is self. It doesn't take anything else because the circle doesn't need any more additional information to calculate the diameter because it already knows its radius. Okay? So I say, well, what's the diameter? Well, it's just 2 times the radius, right? So what do? I take 2 times my radius. That instance's radius times 2 is the diameter, right? So if I go down here and say, let me make sure it's been run, diameter, but it's a method, so we need those. Run, there we go, 2 and 10, right? Now listen, on this line of code, when this is being executed, circle A is a reference variable to some circle, the circle with a radius 1, right? When we jump into this method, what is self-referencing? The exact same circle that circle A references, right? They're aliases. But on this line of code, circle B is being used. Its radius is 5. So when we're in here, this and this is circle B, self's radius is 5 because self and radius B are now aliases for one another. You see? Also, again, this function takes one parameter, right? But I never gave it a parameter. In fact, if I tried to, it's going to be mad. It's going to say, I need 1, you gave me 2. And you're looking at that and you're like, but there isn't 2. So here's the funny thing. You might look at diameter and say, why even put diameter? And listen up, this is very important. Why not put diameter, not a method of that class? Why not just make a function called def that takes some circle, right? And then I say like return 2 times some circle dot radius, right? Right? Why not just make it a function that I can call elsewhere? It doesn't need to be associated with the circle. In fact, this will work, right? Like I could go here and say, okay, print diameter of circle A. It's 2. Right? Why? Well, this function takes a reference to a circle, takes its radius value, multiplies it by 2, and returns it. Do you see? Nothing crazy here. Right? But if you look closely, that's actually, it's exactly the same. Hell, I could call this self, even though it's not in a class. Now this would get me in trouble with the Python police, okay? But you'll notice, like, well, this would actually work just the same way if that function existed outside the class. But I put it inside the class, and then I didn't actually need to give it the circle. But you do, because this is just fancy syntax. You're looking at this and you're like, there's no argument put into here. But we have what we call the implicit argument. And the implicit argument is that. So this is self, okay? Whatever that reference is what's copied, like the reference value in here, like some memory address 77. Self becomes the memory address 77. So self is actually assigned, but we don't put it here. It comes from the implicit one. Do you see? So it actually is there. You just don't see it in between the parentheses where you usually do. All right? Questions, questions, questions. So far, when you look at this code, let me get rid of this one. When you look at this code, in fact, let's finish the class real soon, or real quick. Okay, I'm adding area and circumference as well. Cool. Get rid of these. Also, it looks like we need pi. So up here, it's common to say like, ooh, actually, where do we put that in Python? I always forget. Up here, or is it in the class? I think it's up here. Import math. There. Okay, it works. If I go here and say like circumference. Perfect. Okay, cool. So now, there, look. I finished this class. None of the code in here, except for the funny new things we learned about this class keyword, init, and self, whatever. This is all very basic functionality. Take a radius, multiply it by 2. Multiply it by pi and square it, right? Like, it's all really simple code. So this is what I mean about like taking a step back on like the difficulty. it's not that it's like less difficult, right? But like this is more basic code, I think, right? Like we're not doing a linear search yet or anything. Anyways, we'll end there for today, and have a great weekend, and I'll see half of you in lab today.